Okay, here we go again. What do you see now, Hafsa?
The greatest common factor in factoring by grouping, and then on the right side I see the copyright notice, like right there.
Okay. To the left, do you still see copyright notice?
Yep.
Okay.
Yes.
To the left, you see assignment? Okay.
So I see it.
I see it.
Okay. Thanks, Zay. Thank you all. Thank you. Okay. Starting with find the greatest common factor of two or more expressions. And you saw the check mark, right?
Yes.
Okay, good.
Yeah, I see the check mark.
Okay. Again, thank you all for being patient. All right. Now let's look at this. Earlier, what I'm underlining now, we multiply factors together to get a product. Now we're going to reverse that process. We're going to start with a product and then break it down into factors. So for example, here, where I circled the 2x squared plus 6, we want to factor out what they have in common. They meaning for the numbers and then for the letter. So the greatest common factor between 2 and 6 actually is 2. And then the greatest common factor between x squared and x, well, is just 1x. So I'm headed here, but I wanted to write it myself down here, okay? So when I factor out this 2x, then this is going to leave me with just 1x, because 2x times x gives me this 2x squared. And then I bring down this plus sign, and then 2x times 3 would give me the 6x. And then I'll close my parenthesis. So this is how we're going to be factoring these polynomials coming up. Does that make sense?
Yeah, it does.
Okay, okay. So now let's just move down to an example like this, where it asks us to factor 4x plus 12. So now look at the number 4 and the number 12. Their GCF, their greatest common factor is 4. So outside of my parentheses is where I bring my 4. Okay. I have an x here, and I don't have an x behind the 12, so I can't factor out an x. So now I ask myself, okay, 4 times what would give me 4x? That's just x. And bring down my plus sign. And now I ask myself, 4 times what would give me 12? And that's 3. So when I factor 4x plus 12, I end up with 4 times parentheses x plus 3. Any of this kind of familiar to what you all remember in high school?
Yep.
Yeah.
Okay, okay. That's good. Anybody still writing?
No, I got it.
You got it? Okay. Zach, Isaac, Lexi, John?
All good.
Yeah, I'm good.
Okay.
Good.
Now we want to factor 12x minus 60. So look at what's my greatest common factor between 12 and 60. Well, that is 12. And I can't factor out an x, so now I put my parenthesis, and I ask myself 12 times what will give me x? Well, it's just x. Bring down the minus sign. And then 12 times what will give me 60? That's 5. So when I factor 12x minus 60, it's going to give me 12 times x minus 5. Any questions?
No, it's pretty straightforward.
Okay. 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 So next we have to we have to factor 5x to the third minus 25. It's my greatest common factor between 5 and 25. That is 5. Sorry. Wow. And then the greatest common factor between x to the third and x to the second. Well, that's x to the second. And I write my parenthesis. Now 5x squared times what would give me 5x cubed? Well, 5 times what would give me 5? Well, 1. X squared times x would give me x to the third. Okay, then minus 5 times what would give me 25? Well, that's 5. Then x squared times what would give me x squared? Well, that's just 1, which I don't have to write. So this, this is just 5x squared times x minus 5. When you factor 5x to the third minus 25x squared.
Okay, how did you get 5x squared
Okay.
at the beginning?
Okay, it was Lexi. Okay. When I look at the numbers, Lexi 5 and 25, their greatest common factor is 5. So what I'm trying to do is within the parentheses, I want to take out, well, starting with the numbers, their greatest common factor. And so that number is 5. And then for x to the, you okay with that? Let me stop right there with the 5 and the 25.
Yeah, that's good. And then I
Okay.
don't know how you got the x squared. The x, yeah, squared.
Okay. Next, I look at x to the third and then x squared. It's another way to explain this. Let me try this way. Okay. x to the third is the same as x times x times x. X squared is the same as x times x. So when I ask myself, what is their greatest common factor? Well, they both at least have x squared as a common factor. Okay, how did I get to x squared? Well, the x to the third. Okay, let's try it this way. Let's try it this way. X to the third is x to the first power times x to the first power times x to the first power. X squared is x to the first power times x to the first power. So wow, that's a good question. I've never been asked. Because I can see it, but I'm struggling trying to explain it. What if I do this, Lexi? For the x to the third, if I say x to the first times x to the first, that is x to the second because I had to add my exponents, right?
Yeah.
Okay, but I'm left over with still this x to the first power from here. Okay. Now for down here, I have x to the first times x to the first. And that too is x squared. So now when I look here and I look here, I ask, what do they have in common? They both have an x squared term that they have in common, right?
Yeah, that makes
Okay,
sense.
okay. So now I can pull that x squared out and write it outside of the parenthesis next to the 5. So now I have 5x squared right here as the greatest common factor for what I just circled. So that's how I got the 5x squared.
Okay, yeah, that makes sense.
Okay, so now since I pulled out this 5x squared here, I asked myself, okay, this 5x squared times what would give me 5x cubed? Well, 5 times 1 will give me 5. And I don't have to write the 1. But x squared times what will give me x to the third? Well, that's just x. Oops. And then for my second term, well, I have minus. Now I ask 5 times what would give me 25. That's just 5. And now x squared times what will give me x squared? Well, that's just 1, which I really don't have to write because 1 is understood to be there. So my final answer is when I factor 5x to the third minus 25x squared, it is 5x squared times x minus 5. Does that make more sense?
Yeah, way more sense. Yeah.
Okay, okay. And this is what we're going to be doing with all these. We're going to pull out what they have in common, pull it outside of the parenthesis,
Okay.
and then have other stuff inside the parenthesis. But good question. Good question. Anybody else? I don't want to move on and leave anybody behind or.
No, this makes much more sense. The
Okay.
way you explained it, so I appreciate that.
Okay. And thank you for speaking up. Thank you for not staying silent. Thank you. Make me work. That's what they pay me for. And not being worried about what others may think. Oh man. If more people, not just you all, just in general, whether it's math or whatever, speak up and ask questions. Make your professors work. Make sure they are doing what they should be doing. If they don't, maybe they should find another line of work. Anyway, because this is being recorded, somebody may see it, but anyway, I'm telling the truth. All right. Ooh, now you got something like this. We got 8m cubed minus 12m squared n plus 20m n squared. Sorry about that. Okay, we're going to first look at what's the greatest common factor between 8, 12, and 20. So I can write 8 and then 12 and then 20. And I'm going to write down their factors and see what they have in common. So 1 times 8 and then 2 times 4. Okay, for 12, my factors are 1 times 12, 2 times 6, 3 times 4, and then 4 times 3, which is already here. So I know I have all my factors for 12. Then for 20, it's 1 times 20, 2 times 10, 3 times something, no, 4 times 5, then 5 times 4. So now I want to underline what factors they all have in common. Have a 2, and a 2. They have 4, 4, and 4. So the greatest common factor is 4. And I'll circle that. So that means on the outside of my parentheses, I know I can write 4. We're going to have these parentheses for stuff left over to be written inside the parentheses. Okay. In terms of variables in each term, I have an m to the 3rd power, I have an m to the 2nd power, and I have just 1 m. So I ask myself, well, each of these terms has at least 1 m that I can pull outside. I can factor out at least one of them. Is that part okay? Can we stop right there? Is that all right?
Yes.
Okay. Now I look at my first term again. Do I have an n? Nope, I don't. I do have an n in my 2nd term. My 3rd term, I do not have an n. Since all 3 terms, well, since my first term does not have an n, I cannot factor out an n. So I'm going to leave that, the n's where they are. Now I ask myself, 4m times what will give me 8m to the 3rd? Well, 4 times 2 would give me the 8. And then m times m to the 2nd power gives me m to the 3rd power. Now for my next term, the minus 12m squared times n, I bring down my minus sign. And then I ask, well, 4 times what number will give me 12? That's 3. M times what will give me m squared? Well, just m. And now I just bring down my n. And bring down my plus sign for this third term. So 4 times what will give me 20? Well, that's 5. M times what will give me m? Well, that's just 1 in parentheses, which I don't have to write, okay? Because that m has already been factored out. And now I just bring down the n squared. And so that is it. So I factored out everything that this trinomial had in common. So their greatest common factor was 4 times m. Is that okay? Lexi, Hafsa, John?
Yes.
Yep.
Yeah, that's good.
Appreciate it. That's good.
Okay, okay. Anybody still writing?
Nope.
Okay. Okay, next we're going to factor negative 8y minus 24. So looking at just the numbers, I can factor, well, first let's underline negative 8 and then negative 24. So, okay, well, their greatest common factor, I can factor out a negative and I can factor out an 8. And then write my parenthesis. And now I ask negative 8 times what would give me negative 8y? Well, that's just y. And now negative 8 times what would give me a negative 24?
Plus 3.
That's right, it's going to be a plus and then 3. That's right, Zach. Yep. That's it. Lexi, Aaron, Isaac, Zach, Officer. Still okay?
Mm-hmm. Yeah.
Yeah. Okay. Okay. Factor 5q times q plus 7 minus 6 times q plus 7. Well, the factor that they have in common is the q plus 7. So let's just pull that on the outside of our parenthesis, q plus 7. And I'm using brackets. For no particular reason, I could use parentheses, but just to show you that I'm pulling out the common factor of q plus 7. So now I say, okay, q plus 7 times what would give me 5q times q plus 7? That's just 5q. And now bring down my minus sign. And now q plus 7 times what will give me -6 times q plus 7? Well, it's just 6. Still factoring, even though you got this binomial, that was the common factor. In Newton, you probably want to just go back and change, well, on your own, you want to change these brackets back to parentheses. So it'll still be q plus 7 right here. And I change this first bracket to a parenthesis, 5q minus 6. Change the second bracket to a parenthesis. How was that?
That makes sense.
Pretty
Okay.
good.
Easy.
Okay. Chloe, Lexi?
Yeah, that makes sense.
Okay. Aaron?
Yeah, it does make sense.
Okay. Okay. Okay, next up is factor xy plus 3y plus 2x plus 6. Couple of ways you could do this. All right. Let's start with put parentheses around the xy plus 3 and then the 2x plus 6. So for xy plus 3y, well, what they have in common is y, in parentheses. Now, y times what will give me xy? Well, just x. Bring down my plus sign. Y times what gives me 3y? Well, that's just 3. Now, plus 2x plus 6. Well, for the numbers, 2 is my greatest common factor, so I can pull that out. Since the 6 doesn't have an x, I cannot factor out an x. So I have 2 parentheses, 2 times what will give me 2x squared, just x, and then plus 2 times what gives me 6, well, that's 3. So now looking here, what factor do they have in common for this binomial? X plus 3 is my common factor. So I'm going to write x plus 3, start out with brackets, so you'll see that x plus 3 is what they have in common. So now x plus 3 times what gives me y times x plus 3? Just y. Bring down my plus sign. And now x plus 3 times what gives me 2 times x plus 3? It's just 2. And now I can rewrite this, changing these square brackets back to parentheses. Still good, everybody?
Yes, I just need like 10 seconds to write it. The rest
Sure, sure.
Thank Okay, I'm all good. Thank you.
Okay, yeah, you're welcome. Ooh, do a quick cheat. X. Okay. All right. Factor x squared plus 3x minus 2x minus 6. I'm having a brain lapse. Let me take a quick peek at the screen ahead. Put together. Factor out. Okay. Okay. All right. Sometimes I have to look ahead too. I did it last night, but having a brain lapse. Anyway, let's group together x squared plus 3. And then the minus 2x minus 6. Okay, what can we factor out first from x squared plus 3x? Well, just x. And then x times what gives me x squared? Well, just x. Bring down my plus sign. And now x times what gives me 3x? Well, that's just 3. Now for the minus 2x minus 6, I can factor out a negative 2, parenthesis, and negative 2 times what gives me negative 2x? Well, just x. And then negative 2 times what gives me a negative 6? Negative 2 times what gives me negative 6? It's positive 3. And so now I have x plus 3 as a common factor. So I can factor that out, x plus 3, square bracket, x plus 3 times what gives me x times x plus 3? Well, it's just x. X plus 3 times what gives me minus 2 times x plus 3? Well, it's just negative 2. And then just rewrite this, changing my square brackets back to parentheses. That's it for that one. Any questions or anybody still writing?
No, I got all of it. It makes sense.
You did? Okay.
Mm-hmm.
Once again, Aaron, Isaac, Chloe, Zach, Lexi.
Yep, I'm good.
You good?
Yeah, I got it.
Okay.
Yeah, I'm good.
All good.
Okay. That is it for today. Thank you all for being patient, and thank you for the questions.
Alrighty. Thank you very
Thank
much.
you.
All right. You'll have a good
All right.
weekend, and
You
I'll.
too. Have a good weekend, Mr. Lee. I'll see you Wednesday.
Okay.
Thank you. Thanks for being patient with us, and have a good weekend.
Thanks, Aaron.
Bye.
All right. Bye-bye.
Actually had a question. In the email you sent out,